In section 6-7, we are going to be now graphing the inverses. Yesterday we talked about how to find the inverses if we're given a table of values, or if we're giving a mapping, or if we're given the equation, how to find the inverse. Today we're going to talk about how to graph the inverse. Okay? So kind of neat in my opinion, but then again, like you guys said earlier, I'm kind of weird. So looking at the first example here, we have our original, which is up there in green. That's the original relation. And then we have the inverse that we found yesterday. Okay? What I want to do is I want to graph that original relation first. That original function, I want to graph it. And I'm going to graph it with just little x's so I can tell the difference between my original and my inverse. So we have 0, -1, 2, 0, 3, 2, and 4, 3. All right, so that's the original function they gave us. Okay? And now I want to graph the inverse that we found yesterday. So the inverse, we're at -1, 0, 0, 2, 2, 3, and 3, 4. All right, so once we have those graphed, I want to kind of zoom in here and just really look at what we have. So there's the original with the x's, the inverse with the dots. Do you see a pattern between the original and its inverse?
They bow out oppositely. They're the same. They're gonna make the same. They're gonna make the same points.
They're just opposite of each other.
What do you mean by opposite of each other?
They're flipped.
They're symmetrical. What do you mean by symmetrical? We are reflecting. Yeah, exactly. We're or mirroring, or something like that. That's a great way to put it. And can you kind of visualize the line in which that's being reflected?
Yes.
Think of that. What?
I'm getting the same exact thing
For your points?
Yeah, getting the same exact points for both.
No, you're not.
Put a line through it.
I know 0, -1,
Right.
2,
And this one's at -1, 0,
Yeah.
which is a totally different point.
Wait, -1, 0 because it's flipped.
0, -1, so you go 0 on the x, -1 on the y.
Yeah.
And this is -1, 0, so you go -1 on the x, 0 on the y. Those are two totally different points.
Oh, I know, but I'm getting like the same.
All right, well, it just so happens that yes, we are reflecting, yes, we are mirroring, and it always ends up being mirrored. Hopefully you can kind of see where that axis of symmetry is. Remember that idea with a parabola, how we could just fold it over and it gives us the other half of the graph? Okay, this is kind of like an axis of symmetry, and it happens to be the line y equals x. That line, y equals x, is the line that we are mirroring or reflecting our original equations or functions to get the inverse. Always. Now, why always? Again, think of what we did yesterday. Yesterday, to find the inverse, we switched the x and the y. Right? We plugged y in for x, we plugged x in for y. Well, you can only do that if y equals x, right? And so essentially that's what we were doing yesterday, is that we were taking our x's and our y's, flip-flopping them places, which essentially on the graph was reflecting them to that new spot. Okay? So a original relation or function and its inverse, those are reflections of each other, and they're being reflected around this line, y equals x. Always. Now, you may not think that's as cool as I do, but I think that's pretty nifty. Let's look at a first example of it and see how it works with something other than just a bunch of dots. All right, so let's take a look at the first example on the back of your notes here. Okay. So ignore that red dot there. I accidentally made a red dot that it's not allowing me to erase now. But anyways, we are given a relation y equals x squared minus 1. Okay, and they also happen to give us the inverse of that. Y equals positive and negative square root of x plus 1. So, there's going to be two graphs. Okay, so we're going to graph both of these, the original and its relation, or its inverse, the inverse of that relation. Okay, so looking at that first one, the original one, I want to know first off, is that a function?
Yes.
Yeah, it is. Oops. Yeah, it is. It is a function. It happens to be a, say it again?
Parabola.
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 We learned a long time ago how to graph parabolas. I really hope you remember it. Okay? But I've been around the block a few times to realize that, something 3 months ago, be it math related or personal life related, you may not remember. Okay? So, if you remember how to graph parabolas, hopefully you then know that we were able to find the vertex of this parabola, which would be at 0, -1, and then we would take 2 points to the right side of that, and we would plug in x values to the right side, get those y values, and then we mirrored them to the other side. Okay? It takes me longer to explain it than it would actually take us to graph it. All right? If you don't remember how to do that, then our fallback method was always to plot points. Because graphing these different types of functions had little quirks that we're able to use for shortcuts to graph them. But the fallback method, if you have no idea how to graph the thing, was always to go back and plot points. And so that's what we're going to do here. Okay? We're going to go ahead and plot some points. So I'm going to make a table of values. Now, looking at this, we already know that we should have a parabola. And hoping everybody knows that this parabola is going to be moving down 1, because that's what that -1 means. Okay? But without knowing any of that, we need to plot points, we need to select values. When you're selecting values, do not just pick positive numbers. You want to see both the positive and the negative side of the graph, just in case something's happening there, right? So, let's go ahead and pick -2, -1, 0, 1, and 2. So, looking at those points, now we just plug them into our equation. So what is -2 squared?
4.
4 minus 1.
3.
What's -1 squared? 1 minus 1. 0 squared. 0 minus 1. 1 squared. Minus 1. 2 squared. Minus 4 minus 1. All right, so we have those points. Plot those points, please. Okay, and so once you have those plotted, then you can draw in your parabola. All right, remember doing that? Good. So we have the parabola. Well, we don't want to just graph the parabola. We also want to graph its inverse. Now, they give us the inverse. They tell us up here that our inverse is y equals positive and negative square root of x plus 1. If you remember how to graph square roots, you can go straight to it. Okay? If you don't remember how to graph parabolas, you can go ahead and plug in values, or graph square roots. You can just plug in values of x and solve it that way, just like we did for the parabola. But what did we do yesterday? To find the inverse, we did what? We took the x's and made them y's, right? We flipped the x's and the y's. Whether we were given a table of values or whether we were given the equation, we switched the x's and the y's. Well, weren't the first 4 problems of our homework just switching table of values? Don't we have a table of values?
Yeah.
Switch it. switch it. So F inverse is going to have the table of values of 3, 0, -1, 0, 3 for the x values. And our y values are -2, -1, 0, 1, and 2. Just like yesterday. So, plot those points. Once you have those points graphed, draw your sideways parabola.
Are there problems where they go all 4 ways? Like one problem goes up, the other one goes sideways, the other one goes the other way.
Because you can't have a square root function go through. Right.
All right, so there we go. Now, let's think about what's going on here. Now, you don't have to draw the thing I'm going to draw now, but I'm going to draw in that axis of symmetry, that line that we're reflecting on. Okay? So that line we're reflecting on is that y equals x. So y equals x is this line here. And notice that our two graphs are, in fact, mirror images of each other. The part in the black parabola right here, that is being flipped to the other side and showing up right here.
Oh, sweet.
Okay? This part on the black parabola is just being folded over and becoming this part on the blue parabola. And so on and so forth. This part over here on the black parabola, that's being just reflected over and becoming this part on the blue parabola.
Is it possible to draw a perfect parabola?
Possible? Yeah. Okay. So, there we go. Questions? That's finding the inverse, or graphing the inverse. No? Seem easy? Now, let's do a little bit of connection here. A little bit of connection. If you look at the... all right, let's try doing another one of these. This time it's not going to be a parabola, though. This time it's what? It's a line. Y equals mx plus b. So, how do I graph that line? Y equals 2x plus 8.
You plot points on positive and negative.
I don't want to plot points. I mean, shouldn't we know already how to graph a line? Y equals mx plus b. What's the b?
Oh, y-intercept.
B is the y-intercept.
Yeah.
And what is our y-intercept? 8. So let's go up here to 8. 2, 4, 6, 8. What's the slope?
2.
2. How do I count a slope of 2? Which way's over?
Over to the right.
Up to right 1. But I went off the graph.
Then you go
Down to left 1.
Okay, science.
Science?
Yep, science.
I'm pretty sure.
Science is nothing but applied math, guys.
God.
That's true.
Boom.
And then with the apron go.
All right? So, connecting these dots then makes our line. All right, so that is the original function. We also want to graph the inverse. So, just for giggles here, I'm going to go ahead and draw in the line that we're going to be reflecting around, which is that y equals x. Okay, so we can see that our inverse is going to come out over here somewhere. Right? Everybody see that? Making sense? Okay. Well, now how are we going to find that? Because we said before that we could graph the equation if we had it. Well, they didn't give it to us, so we don't have it. Or we could use the table of values and flip them if we had it, but we don't have a table of values. So what do we do?
You swap y and x.
Okay, so you mean swap y and x in this guy?
Yeah.
Okay, so you want to write the inverse, Right? Is that what you're telling me? Find the equation of the inverse?
Unless there's a better way to do it.
Well, I'm asking you. Is there another way we could do it?
Probably not. There might be.
Yes. Yes, there is.
Okay, so we are going to find the equation by switching the x and the y's. So x equals 2y plus 8. So we have to find the equation that we want to graph. So we're going to have to subtract 8. And then we're going to have to divide by 2. So we get y equals 1/2 x minus 4. How do I graph that? -4 is my y-intercept. Slope is 1/2, so I go where? Up 1, right 2. Okay. Or down 1, left 2. Okay, yeah, I can do that. And then this is my line. Yeah, I can do it that way, guys. But that is not how we graphed the previous problem. It works. And it's not so bad when you're dealing with the line, because graphing lines are really easy. Okay? But when we did the previous problem, we graphed a parabola and the inverse of a parabola, which was a square root equation. We said, hey, let's find a table of values. Right? Well, we didn't have a table of values here, but didn't I plot a whole bunch of points?
Yeah.
Okay, so why don't I write down where those points are? Like that first one's at 0, 8. The next one's at -1, 6. The next one's at -2, 4. The next one's at -3, 2. And the last one is at -4, 0.
Is that for the original?
That's for the original. Yeah, and then let's go ahead and flip them. So then the inverse was at the points 8, 6, 4, 2, 0, 0, -1, -2, -3, -4. And look where they end up being. Where is the point 8, 0? Oh, it's right there. Where is the point 6, -1? Oh, it's right there. 4, -2. 2, -3. 0, -4. Okay? You can go through and find the inverse equation. I'm not going to say it's going to be easy to graph, though. Or you can come up with your own table of values and do it that way. Now, you guys said find a table of values from the beginning. But I personally think, and I could be wrong, if you guys don't believe me, then you can do it your own way. I think graphing a line is easier just using y equals mx plus b. Whereas the y-intercept, count your slope. If you wanted to go through and actually come up with your own table of values by plugging in -2, -1, 0, 1, and 2, and then plugging each number into the equation and finding, if you want to do it that way, then do it that way. Okay? Because again, plotting points is your fallback method for graphing these guys. But I am hoping by this stage in your lives, you can all graph a line without doing that. Okay? All right. Any questions over this process?